Alrighty, so some examples integrating logs. There's one in the last video where we derive the theorem for the log integration. Feel free to go back and have a look at that. I'm just going to do for you two examples today, and then I might do a video later on of just other examples from this unit from the HSC. So some harder questions in there, some things a little bit trickier. But just to start you off, looking at some decent examples, we're going to start looking at the integral of x plus 1 on x squared plus 2x dx. So my theorem says what I'm looking for always, if I integrate f dash x on f of x, I get log the absolute value of f of x plus c. So what I'm going to do, I'm going to look to set my bottom to be f of x and try and get f dash x on top here. So integrating this, I mean, if you're differentiating, you might be reaching for something like the quotient rule or a weird version of the product rule, but you can't really do that in integrating. Integrating is a little bit different. So log integration is a method you have available to you. What I'm going to do, if I do set this here to be f of x, then f dash x, so as a side note, f dash x would be 2x plus 2. And I need the top to be then 2x plus 2. Right now I haven't got that. So what I need to do, I need to modify this to make it 2x plus 2. I'm going to multiply the whole top by 2, which means I need to cancel the whole top being multiplied by 2 as well. So this question that I've got is the same as half of the integral of 2x plus 2 on x squared plus 2x dx. So now, if my bottom is f of x, x squared plus 2x, f dash x, that'd be 2x, f dash x would be 2. So now I do have f dash x on f of x. I have f dash x on f of x. That is exactly what I want. So now we can just go through, put the log in. So this is going to be equal to then a half out the front of the integral of log absolute value x squared plus 2x, close the absolute value sign, throw the constant on as well. That's my answer. It doesn't look like you're going to get logs from the question, but f dash x on f of x will get you a nice log integral. In terms of integrating, it's always something to look out for. It comes up time and time again, can be a little bit sneaky. Grabbing a second example, the second example I want to show you guys today is this example here. It's called example B. Example B, we're going to integrate e to the 2x on e to the 2x plus 1 dx. Okay, so now it looks like we're combining exponentials and logs. Nice. What you want to look for, pretty standard trick. If this is f of x down the bottom here, differentiating that, do you get something similar to the top? Well, if I differentiate e to the 2x, let's do it on the side here. If we say f of x equals e to the 2x plus 1, then f dash x, well, by the chain rule, differentiating exponentials, that would be 2e to the 2x. The plus 1 cancels. So I can make this top here, f dash x, I put a 2 in there. I'm going to put a half out the front to cancel that off. So that then is the form I want for a log. So this is going to be a half log, and it's going to be e to the 2x plus 1 plus c. Okay. In terms of getting fiddly with the cancelling, I wouldn't jump to it too quickly because of the absolute value sign there. Also, you've got 2 terms in there, so trying to cancel might get a little bit funky. But that's my 2 examples I want to show you guys with log integration. Always going for the form f-x on f of x. If you can get that form, log integration every single time. Watch out for it. Do a little bit of fudging around if you need to, but keep your eyes open for this one. Okay. I'm probably going to put some HSC questions up as well. I'll go through some papers, find a few bits and pieces to finish the unit off. But otherwise, thanks for watching, guys, and best of luck with your own integration of logs questions.